Hello friends, I welcome you in lecture number 22 on Laplace transform. In this lecture we will see how to obtain inverse Laplace transform of this type of function 1 divided by s minus a raised to something where n is any positive real number. So to obtain the formula for this L inverse of 1 divided by s minus a raised to n, we have to think that for which function of t we will obtain this type of function of s as its Laplace transform. So if you recall, we have seen this formula Laplace transform of t raised to n is gamma n plus 1 divided by s raised to n plus 1. Now if we apply first shifting theorem, we have Laplace transform of e raised to at times t raised to n is equal to gamma n plus 1, and we replace s by s minus a raised to n plus 1. So here we observe that we have this function s minus a raised to something, and if we require nth power, we can replace n by n minus 1 here. If we replace n by n minus 1, we can rewrite this formula as Laplace transform of e raised to at t raised to n minus 1 equal to gamma n minus 1 plus 1, that is n, divided by s minus a raised to n. And this gamma n is constant, so that I can shift on left hand side, and I obtain that Laplace transform of e raised to at times t raised to n divided by gamma n equals 1 divided by s minus a raised to n. So here we obtain the formula for L inverse of 1 divided by s minus a raised to n. This is equal to e raised to at, because we have s minus a, and t raised to n, here I have to write n minus 1, t raised to n minus 1 divided by gamma n, where n is any positive real number. And if n is natural number, then we know that gamma n can be written as n minus 1 factorial if n is a positive integer or natural number. So we will remember this formula, and whenever we have this type of functions 1 over s minus a raised to something, we will use this formula. So that I have written here inverse Laplace transform of 1 divided by s minus a raised to n equals e raised to at times t raised to n minus 1 divided by gamma n. So here whatever constant is subtracted from s, that we will consider in exponential function e raised to at times t raised to n minus 1 divided by gamma n, and condition on n is n must be positive real number, and if n is a particular natural number, then this gamma n can be replaced by n minus 1 factorial directly. So if n belongs to n, L inverse of 1 over s minus a raised to n is equal to e raised to at t raised to n minus 1 divided by n minus 1 factorial. So we consider two functions and we try to find out their Laplace transform using this formula. First function is 1 divided by square root of s plus 4, and I want to obtain inverse Laplace transform of this function 1 divided by square root of s plus 4. So first I write this function as this, I can rewrite as s minus minus 4 to the power 1 by 2, so that we can compare with our formula our formula is inverse Laplace transform of 1 divided by s minus a raised to n equals t raised to n minus 1 over gamma n times e raised to at. So here we can compare, we can see that if we compare with s minus a, here value of a is minus 4 and value of n is 1/2. So we use this formula and we can easily write down the inverse Laplace transform for this. E raised to at, that is minus 4t, t raised to n is 1 by 2, so t raised to 1 by 2 minus 1 divided by gamma function of 1 by 2, and t raised to 1 by 2 minus 1, that is t raised to minus 1/2, and gamma 1 by 2 is square root of pi, and this we can rewrite again, e raised to minus 4t divided by square root of pi times t raised to 1 by 2, and if we wish we can write in this way also, t raised to 1 by 2, that is square root of t, and we have square root of pi times t. So this is very easy, you just have to remember this formula. Whenever you have this type of nth power of linear factor s minus a, you can use this result, find out value of a and take that a in power of exponential function, and whatever power here you have to subtract 1 from that power and divide by gamma function of that power, e raised to at times t raised to n minus 1 over gamma n. We consider another function in which we will use this formula. Here we have s plus 1 raised to 4, and in the numerator also we have 3s plus 5. So we have to rewrite this function so that we can use that formula. So for that I keep this as it is, s plus 1 raised to 4, and because I have s plus 1, here I write 5 as 3 plus 2. So here you can see, if I write 5 as 3 plus 2, then I will combine these two terms, 3s plus 3, and 3 will be common and I will have s plus 1. So this I can again rewrite as 3 times s plus 1 plus 2 divided by s plus 1 to the power 4, and then this we can rewrite as 3 into s plus 1 divided by s plus 1 to the power 4. So 1 s plus 1 will cancel out and we will have 1 divided by s plus 1 raised to 3 and plus 2 times 1 divided by s plus 1 raised to 4. So we have written our function in such a way that we can use that formula, 3s plus 1 divided by s plus 1 raised to 4. Now therefore now we take L inverse on both sides. L inverse of 3s plus 5 divided by s plus 1 to the power 4 equals 3 times L inverse of 1 divided by this we can rewrite as s minus minus 1 to the power 3 plus 2 times L inverse of 1 divided by s minus minus 1 to the power 4. Now we use that formula. We again recall the formula, L inverse of 1 divided by s minus a raised to n, this is equal to e raised to at times t raised to n minus 1 divided by gamma n, and here powers are natural numbers, so we can use this formula, gamma n will be equal to n minus 1 factorial. So we use this formula here. We can see here value of a is minus 1 because we have s minus minus 1. So we will have e raised to minus t. We take a equal to minus 1 here. and here in the first function power is 3, so I have to write 3 minus 1, that is 2, divided by 3 minus 1 factorial, that is 2 factorial. T raised to n minus 1 divided by n minus 1 factorial. Here value of n is 3, so we will have 3 minus 1, that is t square divided by 2 factorial. Same thing here. Here also we are having s minus minus 1, so we write e raised to minus t. Value of n is 4, so n minus 1 will be 3, so we write t raised to 3 divided by 3 factorial. Now 2 factorial is 2, so we will have 3 by 2 e raised to minus t square, and this we can further simplify. 3 factorial can be written as 3 into 2, and I keep this as it is, so this 2 will cancel out, and we can see e raised to minus t can also be taken common, or we write one more step, 3 by 2 t square e raised to minus t, and here we are left with 1 by 3 t cube e raised to minus t. So we can keep this as it is, or we can take t square e raised to minus t common. So we are having 3 by 2 left in the first term, and here t by 3, 3 by 2 plus t by 3, or we can rewrite this as, by taking LCM, we can rewrite this as 3 into 3, 9 plus 2t divided by 6. So we can stop here also. So the main aim in this lecture is to make students familiar with this formula. 1 divided by s minus a raised to n has inverse Laplace transform given by e raised to at t raised to n minus 1 divided by n minus 1 factorial, and using this formula we have obtained L inverse of this function by first rewriting this function in such a way that we obtain this form, 1 divided by s minus a raised to something. So here we have s plus 1, therefore we will have e raised to minus t. If you are comfortable, then you don't have to write in this way s minus minus 1. You can simply write s plus 1. Okay, fine. So this is all about this session. I hope you like it. Thanks for watching.